SQL Server, like many others of its kind, has a fair amount of intrinsic functions, or functions previously defined and known by the server that can be used by anyone to remove the difficulty and discontinuity when users create their own functions. These functions can take in inputs via parameters and in exchange return a value in accordance with the function's purpose. In SQL Server, these functions are used in select statements, anywhere these expressions pop up. They are very commonly used in SQL Server queries and procedures and have a clear purpose of decreasing complexity, difficulty, and time with SQL select statement creation. One great upside to using intrinsic SQL Server functions is the variability of the functions and the wide range of tasks that can be accomplished through them. This wide range necessitates the functions falling into multiple categories, with some of the major ones being aggregate functions, mathematical or numerical functions, string and character functions, and date-time functions. Aggregate functions bring together a table, column, or a group of data into a single value, such as the average, the count, or the minimum value of that data. This type of function is wonderful for when you have a lot of data and you need to know a statistic about that data, but not necessarily all of the data itself. The next category is numeric functions that perform mathematical processes that, might not be denoted by symbols or might be too complex to try and replicate quickly. This type can find values such as the cosine or the natural logarithm, or even something as simple as addition. This is very useful for any numeric data that needs to be converted, simplified, or needs any other math to be used, by cutting down a great deal of time and complexity. Numeric data types are not the only ones that have intrinsic functions in SQL Server. Strings and characters can also be altered as well. Functions of these categories do tasks such as capitalization, concatenation, conversion to other data types, and more. This category is very useful in streamlining user-entered data, formatting strings, and producing cleaner output. One more notable category is that of date-time functions. This category can find the current date, the time between dates, and even round a date to a simpler value. Overall, SQL intrinsic functions don't just have a single use, but can actually be used in a variety of ways with a variety of data types and queries. In order to use an intrinsic function in SQL Server, you first call the function by its reserved name, a name that you shouldn't use anywhere else in the program, on the line of the select statement, for example, ABS for absolute value, or SQRT for square root. After that name comes a set of parentheses containing any parameters that you might need. The results of the function will show up in a column on the results table, along with any other selected information in left to right order of declaration. Then, the function will run upon execution and give you exactly the desired data you're looking for. So, in class this year, one of the major programs that we worked with was SQL Server. We used several intrinsic functions throughout the semester, most commonly aggregate functions like count, average, and min-max in our queries, and stored procedures to find data relating to our tables and databases. This also can relate to what we have studied with stored procedure creation, and with being able to develop procedures that can call select statements that more efficiently represent the data we want to show. Learning and understanding these intrinsic functions of SQL Server is a great step to take in being able to find data from a database that may not be in a column or in a table. Finally, these functions are used with select statements, something that has been a major topic for this class. Alright, next, here are some examples of when, where, and how that you would use these intrinsic functions. So the first example that I have uses aggregate functions on the employee table in the HRSQL2 database, which is what I'm going to use for all my examples, to find the number of employees and to find the average salary of all of the employees combined. So the code here says select count employee ID as number of employees, average employee salary as average salary, and select from employee. Using these lines of code, we're going to get the result set of one single row, number of employees, 7, average salary, 12,627.1938. So to create this function, we first pick out the columns we want to use. For count, it could be multiple. We chose employee ID. And for average, we're going to have to use the employee salary column. So then we apply the desired functions, count and AVG, and name the columns accordingly, number of employees and average salary. Because built-in columns are not going to be automatically named, so we need to name them. Finally, we finish the statement and we're going to run the query to receive our result set. So the second example uses string functions to make some changes to the data in the depend2 table. We are looking at the names and the dates of birth of female dependents. First, we concatenate first name, last name, and date of birth into a single column. using an intrinsic function. And then we're going to show a capitalized first name and a last name with all of the A's replaced, just to see kind of what we can do with more string functions. So the code used to do all of this is select, concat, depend f namespace, depend l namespace, depend dob, as name and dob. Upper, depend to, dot depend f name as first name capitalized, replace depend l name a $ as replacing a's from depend to, where depend to dot employee id equals 1. So one thing important to notice here is that not all of it is going to be on the same row. The upper and the replace have been entered and moved down a row, and it doesn't change how it all runs. It just makes it easier to see. I've also added a where statement in this example to show that intrinsic functions do not affect the function of this line at all, and to simplify the results out of it. So here are the results. We have first name and date of birth, Jordan, born in May 12th, 1990 at 12 a.m. We also have Rachel, January 25th, 1987 at 12 a.m., and etc. Last name capitalized, we have Kuntz, Clemens, Twain, all capitalized, and then we're replacing the A. So you can see in Jordan, we have a $ instead of an A. Rachel, we have a $ instead of an A, and so on. So the concat works like a plus sign, putting the spaces and data in one column regardless of type. The replace function is also special because it doesn't affect every single line in this function. But even when the conditions are not met, it doesn't cause any issues and it still runs properly. My final example is using numeric functions. And even though I have split them up like this for organization, it's important to realize that any of these functions, numeric, aggregate, date, time, string, character, etc., can be used together, and they don't, not just ones in similar areas. These categories are more of just an imagined thing to help us organize it. So what I wanted to do with this example is look at some changed versions of the employee salary. First, a cubed version, and also a rounded version that is especially useful if you want to simplify and make it easier to do math on a salary. The code used to do this is select employee f name employee salary, power employee salary 3, which shows that we go to the third power as cubed salary, round employee salary 0, which shows that we go to the ones place as rounded salary from employee. So changing lines between functions and columns does not affect the output. It only makes things easier to see. And finally, the output gathered from this statement is Charles, then we have his employee, his cubed salary, and his rounded salary. Sam, salary, cubed salary, rounded salary, and so on. As we can see, the columns stemming from functions and the one coming from an unaltered column work perfectly fine together, and the numeric functions run on every individual piece of data. So next I'm going to quickly show you the actual working versions of these functions. So the first one we have here is the aggregate functions. Go ahead and click execute. And there we go. We can see our result set popping right up with the single line coming from the aggregate functions. Here's our second example. We can go ahead and run this one. And as we see, we get 7 lines, each one having a name and date of birth concatenated, a capitalized, we switched it up now. This one's a capitalized first name and replacing A's in the last name. As you can see, it still works. Nothing else has been switched. It still works just fine. And our third example, right here, we have employee name, salary, a cubed salary, and a rounded salary. It works just fine. And we have 7 lines of data, and we can see that it did exactly what it needed to do, and with only a few lines of code. These examples really show the simplicity that comes with using functions like this. The most amount of lines I have is 5, and that really shows that using these functions takes something that could take an extensive amount of effort into something much smaller. So altogether, SQL Server is a great program with lots of intrinsic functions that help to cut down on workload, time, and the expertise needed to create result sets of data that may or may not be in the tables. They are something well worth knowing if you have any need to work in SQL Server and make for a strong asset that's easy to use and works like a dream. Here are my references, and thank you.